Hello everyone, welcome to my channel. In this experimental video, I'll show you how much cooling power we get from a 127 couple and 6 amps Peltier module with different electrical power feeds. For the experiment, 3 different brands but the same model thermoelectric modules will be used and their performances will be evaluated. This experiment contains only empirical results based on the applied condition and materials. Therefore, I cannot give the brand names. However, I believe that the results of this experiment will be useful in your choices. Although they are the same type, since the current values of different brand modules will be different according to the supply voltage. Therefore, the calculations will be made by providing the same electrical power value, not the same voltage value. During this experiment, we will also produce a 12 volts car beverage cooler. The volume of the box to be used will be 22 liters. Its internal dimensions will be 25 by 25 by 35 centimeters and its insulation will be 3 centimeters thick. During the experiment, both the external environment and internal temperature difference of the box and the cooling power will be measured with different supply powers. Each different brand of thermoelectric modules will be tested in order. According to the data obtained, the cooling off performance, we call COP, of the thermoelectric modules will be calculated separately. I'll be using a 24 watts divided by degree Celsius thermal conductive block for measuring the cooling power of the thermoelectric module. Now let's start our experiment. Now let's evaluate the experimental results. As you can see in the table, different brands show different performances. I think this is related to the semiconductor quality and the manufacturing techniques. However, we can say that when we use it for car beverage coolers, the COP value can be around 0.5 for a 15 degrees Celsius difference. And additional information, I would like to point out here that it would be more accurate to evaluate car beverage coolers that keeps our drinks cold during the journey rather than for cooling purposes. If you put your drinks in the cooler at room temperature, they will cool, but this will take time. Because at this low cooling power, the cooling capacity consumed for the specific heat of your drinks will not be able to reach sufficient coldness for at least some hours. I hope these experimental results and measurements have given you an idea about the thermoelectric cooling efficiency and that the quality of products from different brands may differ. Of course, better results can be obtained with better thermal insulation and heat sinks with low thermal resistance. As I mentioned in my previous videos, thermoelectric cooling performances are much lower than gas cooling systems. However, thanks to its simple structure and low cost, its advantages for devices that need low capacity cooling, such as car beverage coolers. I would be very happy to see your comments and suggestions. If you like this video, please subscribe to my channel and don't forget to like it. Thanks everyone, see you in other projects.